So another complex word problem here. We have a hyperbola and an ellipse. What are the important parts of this guy here? It's that there's going to be shared values. So this sentence here, that the ellipse and the vertices of the hyperbola coincide with the foci of the ellipse. Okay? What that's basically saying here, let's break it into the two parts. Vertices of the hyperbola, that's the vertices of the hyperbola right there. It coincides with the foci of the ellipse. So, gentlemen, so what that means is for my ellipse, if I can get the focal point of that guy, I can get the a value of the hyperbola. Okay? Now, the next sentence is also important to break down. And again, I would just do it piece by piece. It's a lot to read through the vertices on the major axis of the ellipse or the foci of the hyperbola. Lots of discrete vocabulary right there. Similarly, the vertices on the major axis of the ellipse are the foci of the hyperbola. Okay, so the vertices on the major axis, where the heck is that talking about? It's talking about that right there. Okay, then I'm going to identify foci of the hyperbola. Oh, okay, so that's saying foci relates to C. So that means that in this case here, the major axis of the ellipse was the value of A, right? The distance from the vertice to the center is going to be A. And then the foci of the hyperbola is always C. So there's the foci. Okay. So from there to there is actually C. So that means A of ellipse has a relationship with C of the hyperbola. Okay. So lots to unpack there. Before I go any further, it does say that they are superimposed, and all that really means is that the H and K are shared. So because right here, if I look at the co-vertices right now, and I see that the X value is 4 for both of those, that means my H value has to be 4 for both. When I then similarly look at my vertices of the ellipse, I can identify that where that's running through, I would have a K value of 1. Okay, so this center right here is going to be 4 and 1. So that doesn't change between both of them. These two were shared. Okay, you don't have to draw the arrows, they just make sense for my brain. Okay, now from here, I would start to kind of sketch out my major and minor axis of the ellipse, because if I look at the hyperbola, I don't really have much to do with that right now. It's not giving me any values here. It's not mentioning anything in the word problem. So the only thing I can do to start out is break down that the distance between negative 6 and 14 is 20, and that the distance between positive 7 and negative 5 is 12. So left, right is always going to give me an A value. So this is telling me my A is equal to 10. So for my ellipse, my A is equal to 10. You know what that also means? That means the C of the hyperbola is also 10. I don't need to think about it. I just know. Okay? Because I already put the work in and drew the arrow there. Now, what's half of the minor axis? Well, that's 6. So that means that my B value here is 6. Essentially, because they're superimposed, and Jackson, you asked a great question about this, you can sort of look at the diagram as well, identify where the asymptote might be, and because everything is superimposed, we can just assume now that our B value for the hyperbola is also going to be 6, because they're superimposed on each other and they share a lot of similarities. Okay? You can validate it too if you want, but at least we can use that information if we know it. Now, the last part of this guy was, let's find the value of C for the ellipse so I can get the A of the hyperbola. Well, this is a horizontal ellipse, meaning I am going to be using A squared is equal to B squared plus C squared. So the modified version of that to look for C is going to be a squared minus b squared. That should just be on your memory aid. So now I know C is going to be equal to square root of 100 minus 36. So my C value is going to be equal to 8. So that means if this guy is 8, this guy is 8.
So it just doesn't look right on
Hmm?
on the diagram. It just doesn't look like huge.
It's because it's transformed, I think that, and you're right, the diagram doesn't do it justice as well. If you're saying that it's like 20 and 12 and all that, I get what you're saying in terms of focal length and stuff like that. The weird part is we don't like. I really do wish that was closer, right? Because you're saying if this is 8 and that's a distance of 10, right? If that's 8 and that's 10, it really doesn't make sense, right? It would have to be a little bit. So usually the diagrams I rely on, that one I would say is doesn't match. Doesn't match. So at the end of it, we're going to take all of this information and then write out the rule. Find rule. So the format of it is x minus h squared over a squared minus y minus k squared over b squared is equal to a positive 1 because it's left and right. Now I'm literally just going to take all of this information here and then plug it in. So x minus 4 squared all over 64 minus y minus 1 squared all over 36 is equal to 1. And that would be the rule that I'm looking for. So again, very not a lot of similarities between finding the rules of this stuff and advanced functions. Lots and lots and lots of Pythag. Okay? So good to have that in your memory aid. What are the two hardest parts of this style of question? Identifying what the heck they're actually telling you, and also being able to figure out which version of Pythag I'm using to solve for what I need.